and welcome to this HashiTalk session on building resilience and security into your app and infrastructure. My name is Femi Taiwo, and I am a co-founder and CTO at ITIL. We are a technology consulting company and have developed different mission critical solutions in use every day across Africa. I am a Google developer expert on the Google Cloud platform, and I am also a certified cloud architect. I'm one of the co-organizers for GDG Lagos. It's one of the biggest developer groups across the world, organizing some of the largest events. And I am also one of the members of the co-organizing team for TEDx Lagos. During this talk, we are going to delve into different and very important aspects of resilience and security, and best practices for strengthening your app and infrastructure. So whether you're a seasoned coder, a DevOps engineer, or a CTO like me, this presentation is designed to equip you with knowledge and key tools to stay ahead of those who may seek to exploit any vulnerabilities, and to also keep your system up and running even when dealing with massive amounts of traffic or dealing with outages. $450,000. That's how much it can cost a tech company for a downtime of an hour. And that is outside of the reputational damage and impact on organizations and customers who rely on them for work. So in today's increasingly interconnected world, reliable and secure infrastructure is more critical than ever. This talk will then explore practices that empower you to design and manage infrastructure that can handle faults better, withstand disruptions, and at the same time protect you against cyber attacks. So the first question is, what is resilience? Resilience refers to the ability to withstand and recover from unexpected failures or disruptions, while continuing to provide essential functionality and meet performance expectations. Now, that feels like a mouthful, so here's a shortened version of it. It's the ability of an app or system to withstand unexpected failures. So during this talk, I'll be talking on two key concepts in resilience, on code and infrastructure. And we'll start with code level resilience. Handling errors gracefully is important when it comes to resilience. For example, you should always wrap any calls to other services in exception handlers and display or return graceful error messages. And sometimes transient or short-lived errors, which arise from a temporary condition like network issues or database locks, that might be resolved or corrected quickly, can occur. So automatically retrying 2 or 3 more times before giving up can be a good practice. So you can implement retry mechanisms to automatically retry operations on transient errors for a specific small number of attempts. In some other cases, the errors might not be transient. So instead, you can either implement a circuit breaker pattern or a fallback mechanism, which is to either not make continuous retries on operations that are continuously failing, or you can provide alternative actions or data when the primary operation fails. And here is an example of fallback mechanism when one-time password, for example, cannot be delivered via SMS due to network issues or blockers. In this case, the fallback mechanism is to send it in an email or via an automated voice call. Similarly, you should always have reasonable timeouts instead of waiting indefinitely for a response. And if the operation is slow, rather than keep the screen or app frozen, absolutely run it in the background and provide like a progress bar or progress report so that the user is updated on what is going on. Now, it's important to test for resilience using code and evaluate how an application will perform under stress or in chaotic circumstances before it malfunctions. And it's important to know what your baseline is. Lastly, the ability to switch to backup APIs or services when a primary one becomes unavailable is important when this is possible. So you could, for example, be plugged into more than one email service provider so that if one service provider, for whatever reason, is having problems, you can easily switch to another service without having to manually do it, simply by setting up triggers to monitor what is going on. Now, there are many other concepts that I cannot possibly exhaust in this talk, so I'm just going to list more on this slide. Feel free to look them up afterwards. Now, we have spoken about resilience at the code level. Let's speak about this from an infrastructure point of view. There are 9 concepts I would like us to look closely at, and I'll, on the next slides, show some of the best techniques for implementing these concepts that I've outlined here. Remember, infrastructure resilience is essentially a shield, so to safeguard against disruptions. So if you're looking at the first one, which is fault tolerance, and the technique for that is to have backup and error handling. Backups offer a safety net if the server malfunctions. Error handling acts as a vigilant guard, detecting and gracefully recovering from minor faults before they escalate into an avalanche. Setting up multiple servers across and component instances across availability zones allows you to almost like geographically disperse replicas of your infrastructure, ensuring that even regional outages do not cripple your operations. And spreading critical components across availability zones distributes your risks and keeps your infrastructure up and running, even when there are significant outages in certain areas. There is also graceful degradation, which is when you're faced with bigger issues, you can prioritize your core functionality to remain operational, even if some peripheral services experience temporary problems. Auto-scaling and self-healing. Now, this is important to adapt to surges in demand. Gone are the days where you simply just set up 10 servers or 15 servers running, hoping that you'll be able to handle any traffic that comes in, to more modern ways of doing things where you set up auto-scaling and you set up triggers and monitoring to know when there's a surge in demand and to have the infrastructure automatically scale up to handle that demand. Auto-scaling essentially automatically brings in additional resources to handle loads, while self-healing mechanisms quickly repair minor issues to ensure a smooth service experience for your customers, organizations, and clients using your service or platform. You cannot do most of all of this without having real-time health monitoring and alerts. So constantly monitoring your infrastructure is actually essential. Think of it as the days of old, or the ancient days where you had the ancient watchtowers to sound the alarm at the first sign of trouble, allowing us to react swiftly when there's a small issue and prevent those small issues from snowballing into bigger disruptions. Load balancing isn't just about spreading traffic across your servers or services. It's also about routing traffic away from components and nodes that are either malfunctioning, unreachable, or congested. Replication, on the other hand, provides duplicate copies of your data in case of problems or congestion, and regular backups ensures you can always restore your data to a particular point in time and safeguard critical information if the worst kind of disaster occurs. Immutable infrastructure, managing and provisioning infrastructure through code instead of through manual processes is key to consistent and a rapid deployment process. Terraform to the rescue. Terraform is an amazing infrastructure as code tool that enables you to safely and predictably provision and manage your infrastructure in any cloud. There are lots of talk about Terraform during this HashiTalk, so you can listen to them to learn much more about it or check out the documentation online. You can also choose to apply chaos engineering to your infrastructure and create controlled failure experiments to check your level of resilience. And the easy way to do this, or the right way to do this, is to simulate mini disasters like server outages, service outages, to identify and address weaknesses before the real threats actually emerge in real life. It's a chaos engineering here. It's a proactive approach that will strengthen your defenses and increase your resilience level significantly. You can also choose to go multi-cloud, and that is you utilizing multiple cloud providers such that even when one experiences significant issues, and this can happen, and this has happened in time past across even our biggest providers, and if one of them experiences such a major issue that could have impacted you, you're still up and running because you're spread across multiple cloud providers. And you can spread your infrastructure across diverse cloud providers using tools like Terraform to increase your resilience and adaptability. It can feel a bit complicated to do this, and that's why tools like Terraform make it easy to set this up. Now, we're going to move on to the best practices for security, and I'll be touching on the fundamental guidelines you should follow throughout the development and deployment phases of the project. We'll dive into these practices and explore how they strengthen your security posture, regardless of the technology that you use. And implementing any of these or all of these would bolster your security defenses and minimize the risks that you may face on your infrastructure, on your app, or your service, or your platform. The first is around the foundation for secure code. So remember, this talk cuts across not just DevOps engineers and CTOs, but also cuts across to an experienced developer. So the key principle around security is you have to treat security as an ongoing concern and not an afterthought. And what that means is part of the key requirement is you must integrate security practices throughout the entire development lifecycle. And that fits right into the next one, which is defining your security requirements. It's best to define clear security requirements very early on into the project, into the module, into the feature, into the platform, and ensure that whatever code is being written adheres to these security requirements. This makes it easy to set the foundation already to be very solid from a security perspective without having to patch on things later on in the project. And to make that possible, you have to be aware of different vulnerabilities. You have to stay aware by staying updated on the common vulnerabilities and coding practices that introduce them and practices that avoid them. The fourth is the principle of least privilege, and this applies not just for code, but also for infrastructure. We are focused on code in this part of the presentation. So the principle of least privilege speaks to granting users and applications only the minimum level of access that they require for the tasks that they need. And this even cuts across to things like API keys, for example. If you were to be using, let's assume, AWS as your infrastructure, and you want to grant access to your application to upload to S3, it's best to create API keys limited to uploading to S3, but not just uploading to S3, but limited to uploading to specific buckets or specific folders within specific buckets. So by assigning that level of specific privilege, what you've done is the principle of least privilege to that particular API key or to that particular service on your entire infrastructure. The last I'll speak about under the foundation of secure code is defense in depth. And defense in depth is you implementing multiple layers of security to mitigate risks, even what layer fails. Now, I would like to decrypt this a bit more and make it less unclear what defense in depth is. So I'll take a slide just on that. Now, there are multiple principles behind defense in depth, but the idea is, again, to have multiple layers of security in place so that if one layer fails, the next layer can protect your system. So there are multiple layers, and I'm talking about the 5 layers in this slide. The first layer is code security. And you can implement things like static code analysis to identify potential vulnerabilities in the code itself. There are multiple tools to do this. Sastify, SonarCube, and Fortify Static Code Analyzer are some of the best well-known code analyzers out there, and some of them have proved very useful to me in the work that I do. Secure code practices like input validation, proper error handling can prevent the most common attack vectors, but code analyzers will then help identify which ones may not be so obvious in what code has been written. So part of the pipeline, for example, is to implement a code analyzer to run through the code that has been deployed, then determine if the code is secure or not, or identify vulnerabilities that are in it that are obvious to the analyzer and may not be so obvious to a peer review, a code review by a human being. The second layer is runtime security. And 2 easy ways to do that is to set up a web application firewall to filter malicious traffic before it even reaches your application. And there are many tools for doing that. Some basic, some more advanced. And the second bit is to set up intrusion detection systems to monitor application activity for suspicious behavior. The third is infrastructure security. Again, implementing the principle of least privilege, access control, can ensure that users only have access to the resources that they need. You can also segment your network to isolate sensitive parts of the infrastructure. Data encryption in transit and at rest can protect sensitive data from prying eyes or from any kind of data breaches and exposure. The fourth is monitoring and remediation. For example, you should aggregate logs from various sources for centralized monitoring, and a good SIEM or a good security and information and event management tool can help with that. And under monitoring and remediation, you can define an incident response plan which would capture clear steps for identifying, containing, and mitigating security incidents. This is primarily the responsibility of your CISO, your Chief Security Information Officer, or your DevOps engineer at the very least to help with the process in tandem with the rest of your team. The last layer is continuous improvement, which is regular security assessments and penetration testing, so vulnerability assessments to identify and address emerging vulnerabilities using amazing tools to do that. You should also run regular security training for your engineers and operation team to promote a culture of security awareness. Now, leaving that aside, what about securing the code itself? I've already captured this by speaking about code analyzers, secure coding practices like input validation, secure data handling, and proper error handling or error trapping, so that information is not exposed out when there's an error that could not be handled properly. And spoken about static code analyzers, I won't dwell on that. But since we're speaking about securing code, it's also important because nowadays we do end up using lots and lots of libraries and frameworks. So it's best to ensure that you actually check out the you check out the security posture of the framework or the library and ensure that they are strong so that you do not become exposed through that. Containerization, by the way, is also a great way to secure code and secure applications, because what it then does is to isolate those applications and limit their attack surface. Lastly, leveraging on infrastructure as code things like Terraform would help automate security and secure your infrastructure and configuration. Leveraging on infrastructure as code tools like Terraform would help automate and secure your infrastructure configurations. Now, remember the last time you spent hours configuring servers? Yes, it was only fun the first 2 or 3 times, at least for me. So automation became my friend. So automate infrastructure provisioning and configuration using tools like Terraform. Using tools like Terraform, you would reduce the room for human error and ensure more consistency across board every single deployment. It would also help you implement some of the best security practices efficiently and at scale. And the good thing is Terraform also integrates with various security tools for continuous monitoring and remediation. One thing that continually stumps people and exposes people or infrastructure in some case is how you manage your secrets, so API keys, passwords, and key configuration details. So securely storing and managing sensitive information like that is very important. You can connect to Terraform, for example, if you're using Terraform, to tools like Vaults for secrets management. And across different cloud providers, there are tools to help you do that. Identity and access management is very key to securing your deployment. So it's very important to implement strong identity and access management controls to restrict access to resources and to infrastructure. Now, similar to code level security, you should implement the principle of least privilege and utilize tools like Terraform Cloud Workspaces to grant granular access permissions to secure your infrastructure management. Logging and monitoring, we've spoken about this before, so I won't dwell on it, but you can use a tool like HashiCorp Sentinel to drive this. And your incident response, again, showing up here, you have to have a well-defined incident response plan to effectively address security concerns and breaches. Now, I've spoken quite a lot about securing your code, securing your infrastructure, resilience for code, resilience of infrastructure, best practices, and I'll end with tools and next steps. So if you're wondering how you can go beyond traditional access control layers, you should check out Sentinel. Sentinel is by HashiCorp. You can craft fine-grained access control policies for infrastructure. And on the other hand, Vault is a centralized tool for securely storing, managing, and accessing sensitive data like passwords, secrets, API keys, and tokens. The next is Web Security Scanner, which would then help you uncover critical web application vulnerabilities like SQL injection, cross-site scripting before attackers do. And with this, you can quickly identify those exploitable flaws and patch them up, and again, test to be sure that it's been resolved permanently. You can also check out AI-powered insights in threat intelligence on Google Cloud Platform, which then enables you to leverage the power of AI to stay ahead of evolving cyber threats and prioritize risks effectively. Threat intelligence from Google essentially predicts potential attacks so you can prepare your defenses. And by analyzing your infrastructure, it can tell you which attacks you are susceptible to. Consider OAuth your security rulebook and ZAP your testing weapon. Together, they empower you to identify and exploit vulnerabilities ethically on your own platform, just like a white hat hacker. This time around, you do it to protect your own system. The fourth is CASA. CASA stands for Cloud Application Security Assurance. It's a framework. And if you haven't heard about this before, you are not alone. I heard about this for the first time 4 months ago, while I was preparing to get a new platform I built approved by Google. CASA is essentially a roadmap for the CASA framework is a roadmap for gradually strengthening your cloud security posture. And it's a structured and comprehensive cloud security assessment process that starts from the most basic level to very advanced threat modeling. You should totally look it up. Next is JMeter. And JMeter allows you to stress test your infrastructure and applications to uncover performance bottlenecks and potential vulnerabilities under load. So think of JMeter as a virtual army of users simulating massive user traffic. And by testing your system under massive traffic, under pressure, you can identify weaknesses before real attackers exploit them or before your users face them. The last but not the least that I'll touch on here is the Chaos Monkey. It essentially allows you to embrace chaos engineering principles to proactively identify and address single points of failure in your infrastructure. So it allows you to essentially deliberately inject controlled chaos into your system and see how it reacts. So by exposing those weaknesses, you can know what your challenges are and fix them before they cause a downtime in a real attack. Remember the $450,000 loss every hour of downtime that I've spoken about in the first or second slide of this presentation. I will come to the end of my presentation and I'll leave with this piece of information, which is resilience and security are two sides of the same coin. And resilient infrastructure can withstand disruptions and recover quickly. Secure infrastructure protects against cyber threats. And by investing in both, you can ensure your data and your platform is always available and protected. Building resilient and secure infrastructure is an ongoing journey. So it's not exactly a destination, it's improvement over time. So take action, check out the tools presented, and remember resilience and security is everyone's responsibility. My name once again is Femi Taiwo. I hope this has been very useful talk for you. And please hit me up on Twitter. I'll be as well on X. I'll be available as well on the YouTube chat to respond to any questions that you may have. And enjoy the rest of the HashiTalks